same application. So from that perspective, in certain ways, monolithic applications are less complex to deploy because they don't require a bunch of containers or a bunch of serverless functions. Right? So there are benefits to running a monolithic application. However, these days, the trend is definitely away from monolithic applications and more towards the concept of microservices. And so with microservices, what we're going to do is instead of having one big application with a bunch of code that does all of these things, let's take all of these little functions of my application, let's break them apart, right? Let's write the code for a CRM tool, and then we'll write code for a reporting system and a web interface and a database, and we'll allow those components to all communicate to each other using an API. But the basic idea here is that now instead of one big application, right, you'll have many smaller applications, and they'll all be communicating with one another. And there's certain benefits to that, right? Like benefit number one is resilience. So with a monolithic application, typically if it fails, right? If it fails, it's down, it's not working anymore. If there's a bug in the software or something like that, it's just not going to work, right? With a microservices type application, let's say that my reporting function fails. Well, my CRM tool and my web interface, my database, they should all still be working just fine. Those other parts of the application will continue to survive and continue to function, even though I can't access the reporting piece of this application anymore. So resilience is a big benefit. Flexible scaling is a big benefit as well, right? And so, again, let's go with this example application here. Let's say that people are complaining that the CRM tool is slow, right? So the rest of the application working just fine. I can generate reports, no problem. I can access the contents of the database. I can use the web interface, but the CRM tool is not working well. Well, if that's the case, we can just give more resources to the CRM tool specifically. Maybe we run more concurrent Lambda functions. Maybe we run additional containers, right? Whatever we need to do, we can scale up that one specific part of the application. And it's also easier to deploy microservices, right? So for example, let's focus on the CRM tool again. Let's say that I need to make changes, right? My staff is requesting some enhancements to the CRM tool, and we need to get those done. So we focus on writing a new CRM tool. And I don't have to think, it's not like this one big application, right? I'm not updating code that includes all of these other pieces. I'm just updating the CRM tool, right? And when it's done, I can deploy a new function, a new container. I can have a new version of the CRM tool that's communicating with these other pieces of my application. Right? And then I can just sunset the old CRM tool. And I can write all of these different functions in different programming languages as well. Right? So maybe for the web interface, maybe I just want to run something very simple there, and I want to use certain code for that. And CRM tool is going to be different, written in a different programming language. I can do that as well, right? So I can use the ideal type of code for each of those microservices. So yeah, so microservices are essentially an architectural approach to software development, where software is comprised of small, independent services that communicate with each other over well-defined APIs. It makes applications easier to scale, faster to develop, We can run microservices in containers. So for example, ECS is a course that I teach here quite a bit. I teach AWS, ECS, and Fargate. And there's also, of course, Lambda, which we're here to focus on today. And this does introduce complexity, right? And we're going to talk about, well, not so much in this course, but in my ECS course, we get into that a lot, about the need for container orchestration and creating security and allowing all of these microservice components to communicate with one another. Definitely adds complexity for sure. Now with Lambda, some of those things are relieved a little bit, I would say, right? The way you're going to set things up in the AWS console is going to make it relatively straightforward. So it's a little bit different than just running containers. That being said, in Lambda, that's essentially what you're doing, right? You're essentially running containers. That's basically what you're doing, right? So if you're not familiar with containers, we're going to do just like a 5-minute quick Cliff's Notes version of what are containers. And the way I like to think of a container is like a shipping container, right? That's where Docker and containers, that's where that terminology came from. It's like, so let's say I wanted to like take myself and move me from New York, where I am, to Japan, right? But let's say I don't want to buy a plane ticket. I want to ship myself in a shipping container. So I buy a shipping container, I put in a couch, I put in a heater, an air conditioner, I've got batteries, I've got lights, I've got a little stove to cook my food on. I'm in my own little container, which is now my world, right? I can't see anything outside of the container. And maybe a truck comes and picks me up in my container. And maybe I go on a boat, or maybe I fly in an airplane. It doesn't matter. Inside of my little world, I'm living in this container. And it doesn't matter to me which system is actually moving me from point A to point B. Well, that's kind of like a container in the world of software. We create our software in this container. So maybe in a traditional application, a developer writes it on his laptop, but then it's got to go to a test environment, which maybe has different version of the operating system or different dependencies, and maybe it doesn't work quite right. They put it in a staging environment and we have more problems, or we push it to production and there's different dependencies and different, conflicting pieces of software or code that running on those production systems that create problems, right? That's one of the reasons why we started down this road of containers, and allow this software to run in its own little world, just like me in my little shipping container. Allow the software to run within its own little world. And not the biggest benefit of Lambda versus running containers. Now, with Fargate, we're not going to get into Fargate here. That's really a topic for the other course, the ECS and Fargate. On a single instance of my operating system. So it's kind of like the difference between using 4 cars to get 4 people somewhere versus now we're only using 1 car, right? We only need the memory and the CPU resources to run that single operating system. And with Lambda, what you're essentially doing is something very, very similar, right? You're doing something very, very similar with Lambda. So with Lambda, we're moving away from the kind of the traditional concept of containerization and moving into the world of serverless. And what really makes the big difference here, let me go to my whiteboard. What really makes the big difference is, let's say that I wanted to deploy a containerized application, right? Well, let's say I'm using Docker. Right? I'm going to need a container host, right? So maybe this is a virtual machine, right? Or an EC2 instance, something like that. I'm going and scaling and sizing, right? That's all stuff. And these right here, these 3 container hosts are servers, right? So this is not a serverless solution. What we're looking at here are our container hosts. Those are our servers. So we don't want to be bound to servers anymore. Maybe we want to start embracing a serverless application architecture. Lambda is kind of the number one, when it comes to AWS, when people think serverless, they typically think Lambda, right? Lambda is a compute service in AWS, just like EC2. EC2 is also a compute service where you create virtual servers and you manage them. Serverless means that you don't have to manage any servers, right? That's what it means. So, for example, DynamoDB is a serverless service within AWS, right? If I want to create a non-relational database where I can store massive amounts of data at very low latency, DynamoDB is a great solution. And guess what? I don't have to manage any servers. Or S3. S3 is another example of serverless, right? So with S3, I can store as many objects as I want. It's unlimited storage capacity. I don't manage any servers. There are still servers somewhere. You just don't see them, right? You don't have to manage them. You don't have to update operating systems or any of that kind of stuff, right? You don't have to think about putting antivirus on them or whatever. So serverless just simply means we're not managing servers. But Lambda is kind of the primary, serverless. Well, most people equate. If you say serverless on AWS, most people are going to think Lambda. Lambda allows you to run your own code without provisioning or managing any servers, without having to think about, how much are these EC2 instances going to cost and how many do I need, without thinking about managing an operating system or setting up an elastic load balancer to distribute work across EC2 instances. You don't have to do that stuff. So let's think about a web application, right? Let's say that I've got a web application that's running on a set of EC2 instances. And these EC2 instances, these are my servers, right? EC2 is not serverless, right? It's not managed. It's servers. And my application, well, what is my application? It's just code. It's just a software program that has been written. And we're going to install that code, that software in our EC2 instances on top of their operating system. And now I have to figure out how many EC2 instances I need. Do I need 3 to handle my workload? Right? During the day, maybe I need 3. Maybe at night, I only need 2. I can set up an auto-scaling group, right, to accomplish that. But no matter what, you can see here I've got 2 EC2 instances, and they're going to be in different availability zones. So no matter what, no matter how little traffic I'm seeing, no matter how much my website is not being used, I'm always paying for at least 2 EC2 instances, always, 24/7, even if I don't need them. And that's one of the inefficient things about serverless, or I'm sorry, about EC2 and about server-oriented, applications is, you have to have those servers up and running all the time, even if I don't need them. With Lambda, we can run code without provisioning or managing any servers. The Lambda, these are virtual functions. They will execute the code that has been written. Right? So think of a Lambda function as a software application, or as any code that needs to be executed, right? We have to have something executed. We have to have some kind of compute resource to execute our code. That's what a Lambda function is. And Lambda functions are limited by time. So short execution oriented environment. There's certain concepts that are very strange or very kind of uncomfortable about Lambda. And number one is, well, if I don't have a server running, how does this thing work? So that's kind of the basic idea here. I see a question. What's the difference between different types of serverless services like Lambda, Fargate, and serverless Aurora? I guess they have the same operating mechanism, but differs in the features they provide. Yeah, they're all different kind of flavors of serverless, right? So let me just kind of explain them in terms of use cases. With Lambda, you're writing code and you're uploading it. You're creating a Lambda function, which is essentially the same thing as a container. MongoDB, we don't have a database engine like that. It's not relational, right? But with RDS, we've got the contents of our database. Amazon is not accessing the contents of our database. They're not monitoring the contents of our database. So if a change is made to the database and I want to invoke a Lambda function based on that, that's something that I have to basically build my own code for. Versus DynamoDB is a 100% managed service. And yes, if there's a change to a DynamoDB table, AWS can then issue an API call and invoke a Lambda function based on that. So, so I feel like we're getting ahead of ourselves a little bit here. They complete whatever task they need to complete, and then they stop running, and I stop paying for them. So I see another question: if serverless services are paused or terminated, and there are no incoming requests, similar to how Lambda functions work, do other serverless services work the same way, like DynamoDB? Yeah. So with DynamoDB, you've got two pieces of the picture, right? So with DynamoDB, you've got the same, and then this applies to just about everything, right? You've got the compute horsepower, we'll just call it, right? Defer that question for a little bit. All right. But hopefully that made sense for the DynamoDB question there, right? Think of your, maybe we upload an invoice to an S3 bucket, and a Lambda function then runs, processes the invoice, and updates DynamoDB. I could do things like that. I could have SNS. So maybe an alarm is triggered, or maybe something happens. SNS can invoke Lambda. SQS can use Lambda to process messages within an SQS queue. And that's just a little taste of some of the AWS services that have the ability to leverage that. Now the foundation is built. Now your questions are starting to flow, and that's good because we're going to we're going to start answering a lot of those questions that you guys have been asking me over, over the next 3 hours here, where we're going to show how to set up Lambda functions so that there's no Python code, right? This is our Lambda function, right? So this little chunk of code, we can run this, we can invoke Lambda and run this code, right? And yeah, that's what's just happened here. And I'm going to use a blueprint, but I could author it from scratch, right? So I could pick my runtime here, Python, Ruby, Node.js, Java. I could pick my runtime. I'm going to use a blueprint. I am going to create a hello world function in Python. We're going to do everything in Python here. Now, that's just because. So when your Lambda function runs, right? Here's my Lambda function. I just created it. It's called Lambda, right? This is my Lambda function. I'm going to execute the code within that Lambda function. And it doesn't look like much here. You can see right here, it says the status is succeeded. It is similar to a software application, right? Where maybe I've got a software application on my computer. Very similar to those things. Right? So once I invoke my Lambda function, what happens is an execution environment is created. Think of this as a container. A container is created that Lambda function can run within. All of the necessary code is downloaded from like S3, for example. Right? All of the dependencies, all of the data that it needs, whatever that Lambda function needs in order to run, is created in this execution environment. And then the Lambda function itself actually runs in that execution environment. It does its thing. And when it's done running, it disappears. But the execution environment is left behind. It stays. It doesn't stay forever. It stays for a little while. So that if I launch this Lambda function again, this is already done, right? The execution environment's already created. The Lambda function does not have that invocation delay that we saw. It just starts running immediately. And that's the key to avoiding the. So let's see, I keep a couple other questions. Is it possible to pass arguments and parameters to Lambda functions? Yes, it is, absolutely. We'll talk about that in a little bit. Do I have courses? Yeah, I do have courses on Udemy. You may have seen me there. And let's see here. Billing milliseconds versus invocations. Yeah, so basically the Lambda pricing, you're billed per invocation and then per millisecond that those Lambda functions run. You're basically billed for both, right? But your first 1 million invocations are free. That's part of the free tier. We'll take a closer look at the pricing a little bit later on, but that's kind of the basics. So one or two quick things I want to just show you, right? This is a super quick and easy test. It's just going to print 3 values. And you can see here the amount of memory at 3 seconds. And I'll click save. Now, what is the impact going to be because I've given this Lambda function more memory? Right? I've given this Lambda function more memory. And if we look at our tests, the Lambda function was using like 32 megs of memory. It never came close to using the 128 megs that I had. Well, now I've given it twice as much memory. Is it going to actually run any faster? Right. No, it took 1.7 milliseconds still. It didn't run any faster. It's still only, and we can see all kinds of information about our little Lambda function here, and what's been going on in these log streams, right? So I can click on the log stream here, and I can see exactly, every event that's occurring. I can dig deep into those. I can see exactly what's happening as it's initializing. I can see here's loading the function. Here the function starts. Here it produces these values. It eventually ends. Right. So I can view all of that's why your Lambda function needs the ability to write to CloudWatch, right? That's why when we looked at our Lambda function here under configuration, that's why we had to give it permissions to write to CloudWatch logs. So let's see here. I see I've got a lot of questions to answer. How to access S3 from the Lambda function. How to access an S3 bucket. You would have to update these permissions. Right? You would have to update this IAM role to give the Lambda function access to S3. How would you deploy in a real project? Do you write some sort of Terraform or CloudFormation? Do you connect GitHub actions to a CI pipeline? How do you deal with multiple dev, test, and production environments? Yeah, so you could absolutely utilize Terraform or CloudFormation. Either one of those would work just fine. You connect to GitHub actions. Yeah, and you'll see, so you'll see in a moment when I create another Lambda function, how we can connect to things like that. And this is the first Lambda function is just kind of a quick, hey, let's see what happens when a Lambda function executes. Let's see here. Can we install packages for the app? Yes, you can. You can build that into your Lambda function. We will create one in a few moments. What's the maximum CPU and memory that we can assign to Lambda? Let's see, the maximum memory you can see is 10 gigs here. And as you increase the memory, it automatically increases the CPU. What happens if the amount of memory needed exceeds the amount of memory allocated? Well, it can't do it. It can only use the amount of memory that's actually allocated to the Lambda function. So it might just run longer. It might take longer to run. Can we run something inside the Lambda function that is a web server? Yeah, you could run an Nginx web server in this, absolutely. You can see the status here is failed, and it'll give me information about the failure down here under the logs. I failed on line 12. So I just kind of wanted to get you guys familiar with the interface here. Let me go back a little bit. I'm going to delete this Lambda function. I'm just going to get rid of it. And we're gonna try some other stuff in the AWS console here. Okay, let's see here. I see more questions. Let's see. How do we use Terraform? How do we Terraform the Lambda function and Python script it needs to run? Yeah, so I'm not an expert on Terraform, so I'm not sure I'm going to have a great answer for you on that one. Um, yeah, I know CloudFormation a little bit better than I know Terraform. So I know you could do it in CloudFormation. You could have a have it invoke a Lambda function and um, you know, as part of its part of a CloudFormation template. So I think it's probably a very similar process with Terraform. Let's see. In order to build a fully backend system, besides Lambda functions, what AWS services you may require? Yeah, so I would say database, probably DynamoDB. That's a common one. S3 is used constantly. The security pieces change. When you're using managed services like Lambda, um, and we're going to see how to run Lambda in a VPC. So some of the security aspects will come to light then. But things like antivirus and stuff like that, you don't really have a lot of those concerns. You have to think about distributed denial of service attacks. That's an important one. So we'll talk about that a little bit. There is ephemeral storage that is included with each invocation of a Lambda function. Okay, so but I'm just going to use my own code and create, I'll modify the code in this particular version of my Lambda function. Right? I could say Rikishi, AWS, Pearson, or whatever. Right? I can modify this code and create new versions of it as well. Right? And I can also, if you'll notice here, this is the function ARN. So real quick, what an ARN is basically an ARN is a unique identifier for anything in AWS. This version of my Lambda function has a unique ARN, and the other version of my Lambda function has a different ARN, right? The original version. So I can call upon whichever version of my code I need. And yeah, every time you test it, you can see here let's test it again. You can see there is a duration and a build duration. All right, here you see a funnel, right? So if you've ever used a funnel to like fill up your, lawnmower or whatever, you know that, you can pour liquid into a funnel and you can pour it in very fast and eventually the top kind of fills up and then the liquid is kind of slowly going through the funnel, right? And if you pour it too fast, you'll fill up the top portion, but the liquid can only go through this one little narrow part of the funnel, right? So bad job here, right? Because I've given it way more memory than it needs. And it's never going to execute faster because of this. The extra memory doesn't make any difference, right? It's only using 32 megs. So if it takes, let's say 2.4 milliseconds, it's going to take 2.4 milliseconds is guaranteed to get an execution environment. No particular function is guaranteed to not be throttled. Lambda will do the best it can. It's not going to prioritize anything over anything else. That's the default. So here's my Lambda function, right? All of my code, all of my configuration, all of my dependencies, and I've set up a Lambda function. I've allocated it a certain amount of memory. I've given it a timeout, and I can now execute this Lambda function. So this is just code that is essentially sitting here waiting to be executed. And once it gets invoked, now you have one invocation. It needs that execution environment in order to run. The execution environment is essentially a container within, and concurrent executions is currently limited to 1,000 for my entire AWS account for all regions. 1,000 maximum. I can change that by requesting an increase right here. Right? So if I'm going to have to run more than 1,000 simultaneous invocations, I need to request that increase. All right. I can do that here. So non-reserved concurrency or unreserved is the default way that Lambda works. And the basic idea is you have, 1,000 invocations for your entire account, and no Lambda function is given preference. No Lambda function is given priority. So let's say in that scenario, I have like this Lambda function that's absolutely critical, right? That has to run fast. Whenever I want to run it, it's got to run fast. And but I've already got 1,000 Lambda functions currently executing. I've already got 1,000 invocations. It doesn't matter how important that other Lambda function is, it will be throttled. It'll have to wait. There's no prioritization of one function above another. With reserved concurrency, we are prioritizing, right? We're going to set aside a certain number of concurrency units for a specific function. So if you have a maximum of 1,000 concurrent invocations, I could set aside maybe 100 of those and say 100 of those units of concurrency, and you're guaranteeing them at all times to one particular Lambda function, even if that Lambda function doesn't need them. And the other thing I'll just mention is that with reserved concurrency, it does not do anything to improve the invocation delay, to reduce the impact of a cold start. It does not help with that. Right, we're going to learn. What's going to happen is When my Lambda function is launched for the first time, the execution environment is created. When the Lambda function is done, when it's done running, the execution environment is left behind, right? It's still sitting there waiting for the next invocation. Event, because it's got to do things like download code and start your execution environment and import libraries and all of that stuff. Once the execution environment is there, any subsequent launches are considered warm launches.